This video will describe the design and production of this new jig for cutting multi-sided shapes on the bandsaw using the Accu-Slice system. Shapes such as these 6- and 8-sided disc, these cylinders, and even these pyramid shapes were created using this new jig. The idea for this project came about when a customer called asking about using our Accu-Slot system to cut 6-sided Celtic Ring Patterns with this Accu-Slot system. However, in order to accomplish this, these 6-sided disc or cylinders must be perfect. All the sides and angles must be very accurate. So as a result of this, I decided to develop a new jig to enable the cutting of these multi-sided shapes on the bandsaw using our Accu-Slice system. This Accu-Sled system was used in the past to design and develop the Accu-Slot system to produce the Celtic Ring Patterns. Also, a custom fence was made for this carriage to enable the cutting of angled laminated blocks to produce some unique laminated knife handles. And there's videos on our website describing how these projects were completed. So I'm using the same Accu-Sled to design and develop this new jig for slicing these multi-sided shapes on the bandsaw. But first a description of how the system was designed and how it operates. The new jig is comprised of two components, an L bracket support and a series of pattern discs. Both components were designed on the computer using the SketchUp CAD software. The first component is this L bracket support, which is machined from a 3-inch by 5-inch by 4.5-inch wide, 1/4-inch thick aluminum L channel. This L bracket support is attached to the Accu-Sled with these brass keys that slide in the T-channels on the Accu-Sled table. And then these get locked in place with thumb screws, which holds the L bracket support in place. On this L bracket support are sets of 3 vertical spaced holes, each set for a different size of block to be cut. The center hole in each set is a 1/4 inch in diameter to permit the addition of a 1/4 inch diameter shoulder bolt, which fits snugly into the hole. Above and below this hole are 2 1/8 inch diameter holes. These holes will later be used to insert a 1/8 inch alignment pin. The second component for this jig is a series of pattern discs. These pattern discs have a circular pattern of holes to enable the production of the multi-sided blocks. My initial pattern discs were made from MDF. I've also made pattern discs from aluminum and Delrin plastic. All 3 materials work well and will be used for my project. These pattern discs contain a 1/4 inch diameter center hole into which this 1/4 inch shoulder bolt will be placed and then inserted into the same hole in the L bracket support. 1/8 inch diameter holes were drilled in a circular pattern around the center hole at the same distance as the spacing of the holes in the L bracket support. The number and angle of holes determine the number of sides that will be cut from the blocks of wood on the bandsaw. The various pattern discs are for various diameters of projects that will enable the cutting of blocks from 1.5 inches up to 5 inches in diameter. I made pattern discs to cut 5, 6, 7, 8, and 10-sided shapes. To use this system, a block of wood is attached to the selected pattern disc with double-sided tape. And then this gets attached to the L bracket support by inserting the shoulder bolt through one of the holes in the L bracket support plate. And then this gets secured in place using a thumb screw. This locks the system in place. Next, a 1/8 inch diameter pin is inserted into one of the holes in the L bracket support plate and then slid into one of the holes in the pattern disc. This holds the system in place while it can be cut on the bandsaw. After each side is cut, the pin is advanced to the next hole in the disc and the next angle is cut. The process is continued until all the sides have been cut. In this first part of this video, I'll describe how this jig was made and designed and constructed. I'll then describe its operation on the bandsaw for cutting some multi-sided discs, cylinders, and pyramid-shaped projects. From a 3-inch by 5-inch, 1/4 inch thick aluminum L bracket, I sliced off a piece 4.5 inches wide on a horizontal bandsaw. I have my plate all ready to start drilling holes for this new jig, and I did lay out the design in SketchUp. I have a couple parallels on my vise here. And get it tightened up and ready to start drilling. And the holes I'm drilling are 1/8 inch in diameter. According to the SketchUp designed pattern, a set of 3 holes are drilled equal distance apart. After completion of the set of 3 holes, additional sets of 3 holes are drilled according to the pattern. The center hole in each of the sets needs to be a 1/4 inch in diameter in order to fit these 1/4 inch diameter shoulder bolts. So I changed my bit in the mill to a 1/4 inch, and now I'll be drilling the 1/4 inch center holes for each of the sets of holes. On the bottom of the L bracket plate, I then drilled 2 1/4 inch diameter holes to enable the L bracket plate to be attached to the Accu-Sled. And that completes the drilling of the L bracket support plate. Okay, I'm making these discs which control the number of sides I get on a hexagon or an octagon piece on the jig that I'm making. I made the original prototypes out of aluminum, but I've since gone and I'm making them out of this Delrin plastic. So I'll be making 2 sets. One is 6-sided, one 8-sided, and I'm making actually in 3 different sizes for 3 different sizes of boards. And I'm doing this on my mini mill, and I don't have a rotary vise for my mini mill. So I did the calculations on how to space out these 6 pieces on SketchUp, and I have my dimensions here, everything I need to do. In this case, the holes are going to be 1 inch from center. So I have my center position marked, and I'll go ahead and drill my center hole. And I zeroed out my gauge up here on my X, Y, and Z, or 0 to 0 as a starting point. A 1/8 inch diameter hole is drilled in the center of the disc. This will later be enlarged to a 1/4 inch diameter hole. Then, according to the SketchUp pattern, 1/8 inch diameter holes are drilled 1 inch from the center of the disc, using the dimensions that were calculated in the SketchUp software. I do have a direct readout system on my mill, which permits me to position my holes to an accuracy of better than 0.0001 inch. The remaining 1/8 inch diameter holes are drilled according to the plan. As a final step, the center hole is enlarged to a 1/4 inch in diameter, and then countersunk to fit the countersink on the shoulder bolt. I'll later cut flats on this disc to make it easier to align the pins. Two brass keys are slid into the T-slots on the Accu-Sled plate. Then 2 thumb screws are used to attach the L bracket support to the Accu-Sled. The 1/4 inch diameter shoulder bolt is inserted into the pattern disc, which is then inserted into one of the holes in the L bracket support plate. A thumb screw is attached to hold the plate in position. And then the way this works is I have a 1/8 inch pin, slides through the hole in the plate, and then likewise through the hole in this plate. I cut my angle, pull the pin out, rotate it, 60 degrees, do the next one, and keep doing that, going around. Put my center pin in here, and I'll put some double-sided tape, and I'll attach it to this small block of wood. I'm using the X-Fasten double-sided tape available from Amazon, which I've used in other projects. In order to better hold the wood block to the pattern disc with a double-sided tape, I do recommend clamping the pieces together to set the tape. Also in the future, I may be drilling some additional holes in the pattern plate to enable the block of wood to be screwed to the plate. And you can see why these things had to be offset up higher, because there is 3 1/4 inches, but I need a clearance for the bottom when I'm doing a square piece of wood like this. That's why it's been offset. And let me work on my pins, and we'll start cutting some. Okay, I just mounted on my bandsaw, and I have a 3/4 inch wide blade, 14 teeth per inch, the blade I normally use for making segments. And I have my system mounted on here. And what I'm eventually going to do, I'm going to eventually put a handle on this so it's easier to hold. It's a little bit hard pulling out because it's so small. So I have my hole. And there's our completed 6-sided disc with perfect angles and perfect sides. Okay, I'm going to try something else different on this. Instead of keeping this piece of angle here perpendicular to the blade, I put it at like maybe a 45-degree angle. So I should make a 6-sided disc that has angles on it. So let's see how that works out. And here we have our 6-sided disc with 45-degree angled sides. Okay, what I'm going to do now is I'm going to put this on my jig here, and I'm going to cut the flats close to the 1/8 inch diameter hole, just to give a flat. It makes it easier to align your boards as you're cutting them in the future. Since this pattern disc is made of Delrin plastic, it's easy to cut on the bandsaw using my same 14 teeth per inch bandsaw blade. And I'm cutting the sides about 1/8 of an inch away from the pattern holes in the disc. These flat sides on the pattern disc make it much easier to align and insert the pins into the pattern disc. Another modification I made, I added a handle to the 1/8 inch diameter pin to make it easier to insert and remove from the disc. Okay, here's a piece of walnut, and I'm going to do the same thing. I'm going to cut this 6-sided and then do a point on the top. Next, I rotated the support plate to 45 degrees and moved the wood block to the center of the bandsaw blade. And this is the resulting 6-sided cylinder with a pyramid-shaped top. Okay, this is a larger piece of wood. It's about 4 inches square, about 1 inch thick. On this block, I first cut the 8 90-degree sides. What I did discover in making these multi-cut pieces, it's better to cut the sharp angle faces first and then cut the 90-degree faces afterwards. Eliminates any burrs you get on the edge, gives you a much cleaner cut. And this is the resulting 8-sided double cut disc, just to make a nice base for some other project. I just finished cutting this cylinder on my system here, and it's not parallel. In other words, the sides aren't parallel. Like on this side I have 1.69, and over here I have 1.71, so it's off like 20 thousandths of an inch. So I determined what the problem was, is this front plate was not perfectly parallel to the front edge of the Accu-Slice plate. So I adjusted the angle. I used a digital angle measuring system to adjust that plate so it's perfectly 90 degrees to the edge of the Accu-Sled plate. The other thing, I added a tail stop plate to the back side of the long block. The hole position is the exact same position as the front plate, and again that keeps everything centered and parallel, so I should get a much better cut. Yeah, we're within 10 thousandths top to bottom. That's much better, and all I did is I made this plate here, made sure it was perfectly perpendicular to this edge on my Accu-Sled. I did make a few changes to a system to improve its operation. One of my first changes was I put a handle on this 1/8 inch pin to make it easier to insert it and remove it from the holes in the jig. I also rounded off the tip just a hair so it's easier going in and out of the holes in between the plates on the system. So that works much better now. The other thing, I put 2 handles on my sled to make it easier to handle as I'm moving it in and out. And I also added a stop on the rail. This controls the furthest position that the system goes, so it doesn't go beyond that. If I'm pushing a board through here, it won't slip on me. So that was another addition. Also for cutting boards, I've been making sure that using a digital system to measure the angle, to make sure it's exactly at 90 degrees to the sled. That gives me accurate cuts. And then I've made a tail stop for cutting longer boards to make them more accurate. It's still not 100% perfect, but it's more accurate than not using this. There's still a couple shortcomings of the system, and the first shortcoming is cutting these long boards. And I think the system may need a redesign, maybe putting this on a rail that's more accurate, to get more accurate, straighter boards. So I'll be working on that. My other concern is this blade guide is so high that this blade's exposed a lot. And it's really an issue when I'm here working on a board and I'm turning it, and this blade's still going in my hands here. I think it's just too close. So I got to look at some sort of blade guard system here or something to eliminate that issue. So the system's not ready to commercialize yet. There's a few changes need to be made. We'll be working at it. It does work good for doing these small pieces. Making these, and I'll run this through shortly just to show you how this works, but that did work quite nicely. My main concern is doing the long boards. Okay, this pattern disc is 8-sided, and I'm cutting my first angle, trying to get a center point at a 30-degree angle. Just been set at 30 degrees relative to the fence. This is the result of the 8 faces cut at a 30-degree angle. I next reset the angle to 60 degrees to do a second cut on this project. I also moved the block so that the bandsaw blade starts cutting about 1/2 inch from the center of the board. This is the result of the double 8-sided cuts. For the third and final cut in this project, I set the angle to 90 degrees. And this is the final shape of the resulting project. All 8 sides, 3 different cuts. I have another idea for this jig which might have some application. Coming off the bandsaw, there are a lot of saw marks in the surface of the piece. I don't know if you can see them on the video there, but they're significant, and it didn't quite come to a point. So the question is, could this same jig be used on a sander to square off these edges? You know, the angle's already marked, you know, with this pin, and by putting another stop or an angle on the table on the sander, I get my second angle, and I should be able to do this to at least touch up my angles, and we'll see how it works. So let me give it a try. This may mean a new jig in the future that maybe slides on a rail or something to give me some accurate cutting here. So let me just give it an initial try to see how it works. And that actually worked quite nice. Got rid of all those saw marks. If I went to a finer sandpaper, it'd even be better. So let me do the second angle here. So it won't take much to make a jig that I can control the movement, angle-wise, and also the movement in. So that's another jig I can be working on. So I need to change this angle now to a steeper angle. Okay, I just gave this a final polish on my buff sander. So let me get this a coat of bush oil and see what it looks like. So there's a coat of bush oil on that. So that's my next modification to this jig, is to modify my disc sander to sand these. I got rid of all the saw marks. That came out really nice. Here's a summary of some of the shapes that were cut with this new multi-sided jig for the bandsaw. Starting with these 6 and 8-sided disc, and then 6 and 8-sided disc cut at an angle, and then multi-angle 6 and 8-sided cuts on a disc. And this one actually was a 10-sided disc cut at 5-degree positions to give a unique pattern. Some pyramid shapes. Again, 2 cuts, 1 square cut and 1 at an angle. Some hexagon pieces with pyramid shaped tops, and then an angled 6-sided piece, and then some 6-sided cylinders. The multi-sided cutting jig described in this video is a prototype jig. Additional modifications and refinements will be done to this jig to improve its performance and accuracy, especially when cutting the long 6 and 8-sided cylinders. I'll be turning this design over to my 2 engineers and machinists to get their input as to how it can be improved. If you have any comments or suggestions, we would be glad to hear from you. And again, once again, thank you for watching this video.